Hello, everyone. I hope you are all okay. Um, we are now on the fourth workshop of the Generative AI Educate Series. And today we have Boyuan Chen from Enya Labs, who will be giving his workshop on developing Prezi Bot with HybridCompute. He's just getting ready to join us right now. And I hope you guys are looking forward to his interesting workshop. Hello.
Hey, Jenna, thank you. Yeah, thanks everyone.
Cool.
Yeah.
Whenever you're ready to share your screen and begin, the stage is all yours.
Hey everyone, so I'm from the Enya Lab and I'm the principal algorithm lead. And today I'm going to talk about the Prezi Bot. So what's the Prezi Bot? So let's imagine that you have a game where users can engage to answer questions, and questions generated by ChatGPT, and all questions will be submitted on-chain, and the user's answer will be submitted on-chain, and the ChatGPT will pick the best answer and also push the result on-chain. And whoever is selected as the best answer will get 100 free tokens. So this is a general idea of the Prezi Bot, and also it uses HybridCompute, and also it uses ChatGPT to generate the questions, and also it uses ChatGPT to select the best answers. That means all answers submitted by the user will be submitted to the ChatGPT, and ChatGPT will select the best answers from those submissions. So that's how things work in this example. So I can go through with a quick demo to show you guys how this works. Then we can go into the details, like how the code is implemented and how you guys can write how you guys can use the SDK from our end to set up like the server and also the front end. Yep. So let me change to Chrome. Okay. So here we go. So oops, let me set up the wallet first. Yeah. So right now, if you want to use the HybridCompute, you have to install the MetaMask Snap, which is a beta version of the MetaMask, which allows you to install an extension. But very soon, like in 1 or 2 days, the extension will be published to the actual MetaMask. So you don't have to install the Snap MetaMask. So currently, I will just use a Snap MetaMask to do the demo. So yeah, let me enter my password. Oops, sorry. Yeah, here we go. So then you basically need to connect your wallet. Let me go through the whole step so you guys know what I'm talking about. So let me disconnect. Okay. So we basically have one web page called the HC Wallet Disposable Network, which allows you to install the Snap and also create an account. So if you go to the create account here and you create an account, I will basically create a new account for you with like the deterministic addresses. So the next time, for example, if you remove this and also click create account again, then the wallet address will be the same. So yeah. So now we go back to the PresiBot website. So I've already created the Snap account. I will use the first one. There's no balance for the second one, so I'll just use the first Snap account. I connect. Okay, so I connect my wallet address. Let's double check. Yep, so it's here connected, and you can see wallet address. Then go to today's question. Yeah, so you can now see the question from generated by ChatGPT, and you can provide your answers. For example, hi, this is good. This is a really good question. Thank you. Then you can just click submit answers. Yep. We currently using the account abstractions for users to submit the transactions, but also you can use the standard transactions. I mean, use the standard method, not the account abstraction. Just use the standard MetaMask to submit. It will also work. So yeah, okay, it's submitted. Okay, so answer has been submitted. Okay. Yeah, so we will call endpoint. and submit the result, which means you also pick the best answer if everything works. So currently we are not deploying everything on AWS, so sometimes it might be failure, sometimes it might be slow. Yeah. So let's wait for probably yeah. So oops. So it shows the error well. So try again. Yeah. So this is not stable, like I said, because we are not. Yeah. So currently it's working. Yeah. Because we didn't deploy it to the AWS. So it might be like some laggings or whatever. So I think it should just work. Yeah, I think it should work. If I go to this question, yeah. So I'm the winner of today's questions, like this question. I can regenerate a new. I can regenerate a new game. I can start a new game. That will call it endpoint get daily questions, and also the daily question endpoint will call the ChatGPT to generate a new game. Oops, what's going on? Let's try again. Yeah. Anyways, I think that's the endpoint issue. So yeah, but I think you guys have already got the idea. Yeah. Oh, oops. Yeah, but I think you guys have already got the idea. So let's go back to the presentation. So yeah, so let me show how this whole idea work with the HybridCompute and also with the ChatGPT. So this is how the whole things look like. So we have a smart contract called the Prezi token smart contract, and this is the center of the whole idea. So basically, the admin can call the smart contract to get the daily question, and also it can call smart contract to submit result. And for users, what they can do is they can submit their answers for each question that they get from the front end and submit the answer to the smart contract. So once users have already submit all questions to this smart contract, then this smart contract will call the off-chain RPC endpoint. The off-chain RPC endpoint then will call the OpenAI endpoint to select the best answers. And how does the off-chain RPC to retrieve all submission from users? It will use a smart contract to retrieve all answers. It's basically deploying only Boba Sepolia. So it will call this a smart contract and it's from Sepolia, then it will provide all answers to the able AI, then OpenAI returns the best answer to off-chain RPC endpoint, off-chain RPC endpoint, then return to this smart contract. So that's how things are working. Yeah, so let's go deep into this code implementation. I will show you guys a small snips of the code, and we can go deep into the code base later to show how the whole thing is implemented. So here's basically the smart contract called get daily question. You can see it's encoded the signature. The signature will be submitted to the off-chain RPC endpoint, which is called HA call off-chain, and all these HA smart contracts is will be provided by us. So just need to copy and paste the HA smart contract to your folder, copy and paste, and drop it. Then just import these functions, and everything will just work. So we have already packed everything for you. What you need is like just provide the signature of the off-chain, then encode it, encode the sender address, and also provide this user key and the question to the off-chain RPC endpoint. Yeah. Now this is an example for this off-chain RPC point to create the question. So we provide the SDK for you to create a server, so you don't have to go deep inside to, for example, the Flask SDK, Fast API or the Flask. You don't have to do that. You just need to import the SDK, then use the server, you just functions and OpenAI quick function. This is basically the functions you wrote, you write. Then you add the selector. It's basically this here. So basically provide the same selector in the backend RPC endpoint and also in a smart contract. Then you redress the server endpoint. Yeah, so that's it. Then inside the functions, so in this example, you basically use I use a long chain conversation chain to import this OpenAI interface. And you provide the LM. It's called the OpenAI model. Then you add the prompt and generate the response. Then finally, you can encode the response into a string. Then the string will be pushed back to a smart contract, things like that. Yeah. Then I think the most interesting part, maybe one of the most interesting parts, is the prompt. So because this project was developed like a year ago, at that moment, there's no JSON response, so which makes things a little bit complicated. But right now, I think you guys all can use a JSON response for ChatGPT. Then you can ask ChatGPT to generate a response in a JSON and handle it in the backend, so you don't have to worry about like the style or something like that. But this is the current structure looks like. So like I said, your response should be only questions. So in this way, I restrict the ChatGPT to provide the questions just in a string format without anything else. Yeah, and also here I provide some example informations for ChatGPT to consume. Yeah. Yeah, so let's now go to this question selection part. So how does the ChatGPT select the best answer and provide and push the result on chain? So yeah. So now we go to the select best answer section. So this is almost the identical to this previous part, like how you generate the question. So you also have another function called submit results, and it's encode the off-chain RPC endpoint method, select best answer, and also you need to encode the sender address, and you call this HA smart contract. HA is a smart contract provided by us, so you don't have to worry about that. And call the call off-chain, and provide user key and the questions request, then submit to it. Then yeah. Now let's go to this off-chain RPC endpoint. So it's almost identical with the previous one. So you need to provide the selector, which is called the select best answer. Like I said here, it's the same. So then you use a get current round question, which we'll call the Boba Sepolia blockchain endpoint to get the current answer. Then you also call the Boba Sepolia endpoint to get get the questions. So this gets question and this get all answers. So basically, you call the blockchain and retrieve back the questions and the answers that user submit. Then you provide this to the ChatGPT. You basically format it into the prompt and tell ChatGPT, okay, this is questions I generated, and also this is all answers that user provide, and you pick the best one. And the magic here is I tell ChatGPT, okay, so I basically index the answers from the 0 to this last one, so I can know, okay, which answer ChatGPT is picked. Then I which answer ChatGPT picked, then I submit this index. So I basically use this index to get the player's address. Then I submit the address. Then I push back the address to smart contracts. Now in this way, we know that, okay, which address submits the best answer. Yeah, so let's can take a look at the prompt. So yeah, so basically, I tell ChatGPT, okay, you have to index this best answer starting from 0. Then the questions is provided here, and the answers are provided here. So, and also I tell ChatGPT, you must provide the index of the best answer no matter what. Because sometimes you can't restrict the ChatGPT to response or the LM to response something that you want. So you must tell him, okay, you must do this. Then it probably will do this, but sometimes it still answers something unrelated to my prompt. But yeah, but anyways, currently I think there are more like interesting tools that you can use. For example, the base model, you can provide you can provide base model in the ChatGPT, something like that. But currently, yeah, but because the project was developed like a year ago, at that moment there's no such great tool. So yeah, so what I can do is I basically force a ChatGPT to provide the index of the best answer. So yeah, so yeah, so here's how users can submit their answer to this smart contract. So these sections has no has no relationship with the HybridCompute. It's a purely using the smart contract to record the answer with your address. So that means if you are the user, you don't have to use the HybridCompute. You can just use the standard wallet. You don't need account abstraction. You can just use a standard wallet to connect and also submit your answer. So it's purely standard smart contract side. Yeah. So. And also there's functions. For example, if users have already played the game for more than 7 rounds, then it will claim rewards or something like that. So yeah. Yeah. So that's basically the whole idea of this Prezi Bot. So I will show you guys go deep into the code base and let you guys see, okay, how these things is implemented. And if you want to use this example, what kind of SDK you need to use to give you guys a high level overview about the whole code base. Yeah. Let me check. Do you guys have any? Oh, too small phone. Sorry, guys. So I will go dive into a code base. So I will also enlarge the text so you guys can see it. So yeah. Okay. I can share a link in a chat in case you guys want to take a look later. Yeah. So this is our repo. It's a public repo. So yeah. So okay. So this is our code base. So as you can see, there's 3 parts. I think you guys might be interested. One's called the backend, and another is smart contract side, and also the front end. So let's go step into a smart contract first. And in the smart contract repo, you also have another folder called smart contracts, which is very identical ways to construct these folders. So the smart contract here is called presim token. So ATT, yeah. So you can see here. So we basically import the HybridAccount smart contract, which is also referred to HA smart contract. So all these smart contracts are identical, so you don't have to worry about it. I think it's also already in the SDK, and also you can just copy and paste these smart contracts from our repo and put it inside into your project, something like that. And also, yeah, so it's a super standard smart contract, so you don't have to worry about it. You don't need to touch it. If you touch it, something might go wrong. So please don't just copy and paste this smart contract and import it in your project. So like here. So okay, so now we import this hybrid account smart contracts. Now we go to the gather question section. So the HA is basically, if you check the HA, it's basically the hybrid account address with the demo address. And demo address, you can get a demo address from our docs. It's basically the something called the hybrid account address, but you can get it from docs. So yeah. So let's go back to the get data question. So if you check the get data question, it's very standard. So we basically create this signature, create question, which is also the identical from the backend, also called the create questions. Then we also encode the sender address, which is admin. Then you call it off-chain RPC endpoint, use the HA call off-chain. Like I said, don't worry about it, just directly use it. Then you need to check the error. If error is not to equal, that means something goes wrong on the backend. Then you, if the error is equal, that means everything is fine. And you check the IET return. If the error is not 0, that means something goes wrong on the backend side. So you can emit this error message, so you can check. And also you need to refer this this question. So it's showing like error fetching question, something like that. So let's go back to this backend side to see this create a question logic. So if you want to check the backend, just go to the backend. Then you go to this. So the entry point is called this OpenAI off-chain. So, oh, oops, sorry. The entry point is off-chain. So yeah, the entry point is off-chain. So as you can see, the HybridCompute SDK is imported here, so don't worry about it. You don't have to worry about, for example, the Flask server or the Flask server, something like that. You just need to import the HybridCompute SDK. Then you initialize this class HybridCompute SDK. Then you create JSON RPC server instance, and you add the server action, create questions, and this should be the same as you provide in a smart contract. Now we go to this OpenAI create question, and this is the handle of this function. So you go to this. This one is in the OpenAI off-chain Py file, and for this input, all these inputs should be identical. Don't touch it. All you need is this. I think you don't need to touch this input. Basically, we provide this pass request SDK for you, and SDK is also this HybridCompute SDK. So we provide this pass request for you, so you can get these things you need. So for example, you can get the request you need, but currently we don't need the request because you don't need to like decode the request. So currently I will not touch that in this example. So, but you need to use SDK to pass this request. And also if something goes wrong, then you need to generate the response with the request. So that's all you need. And also that's all you need to be careful about. And in this generate response, what you need is a request, error code, and also response. So if something goes wrong, then you return an error code. If everything good, then you just like encode the string that you can decode on the smart contract side. Then you provide in this generate response. Yep. So let's go into this example, like how the off-chain RPC endpoint handles everything. So yeah, so it's just so it's super standard. All these are just copy and paste. You don't need to touch it, like I said. Then you provide the prompt, templates. Then you use a long chain conversation chain to generate a response. Then you put this prompt in this conversation.run. You provide the input. Then if everything good, then you encode this response into the string. Use the is ABI. Then you generate a response in the SDK using SDK. Put the request here. Put the error code here. If everything's good, then error code is 0. And you also put the request here. And you patch everything in the SDK will handle the logic for you, so you don't have to worry about that. So that's how things working currently for this create question section. Yep. Now we go back to this smart contract side. Then we can talk about like submission, question submission, and also the others. Yeah, so this is submit results. So you basically so you basically can submit the results by yourself. Yeah, wait a moment. Yeah. So basically you can submit these results. No, the submit result is for this final. So yeah. So this is here. That's how you can submit the question to player. Yeah, in a moment. Let me quit my stack just in case. Yeah. So and also wait a moment. Let me quit my Telegram just in case. Yeah. So so you can submit your answer to this smart contract. So let's assume you are the player, then you need to submit your answer to this question. Also, this is here how things work. So this is just a pure smart contract side. It doesn't touch the HybridCompute, and also it doesn't touch the other stuff. So yeah, so it's super standard. Yeah, the answer is provided in a string type. Yeah, then if you have already answered more than 7 rounds, then okay, then it's okay. Then you can get some rewards, something like that. So it's there's no magic here. So the another place that use the HybridCompute and also the AI side is called the submit results. So the submit results is basically they will call the off-chain RPC endpoint to get the best answer and also submit the index on-chain. So in this way, we can see, okay, we decode the address from the off-chain RPC endpoint. So here, so we call the off-chain RPC point. So we encode this signature, select best answer, and also this user key, which is the sender address. So we call the off-chain RPC endpoint, then we can decode this return because we assume that the return that we will give is an address. So we decode this address, then we set, okay, this game ID, the winner of this game ID is this address. So yeah. So yeah, so let's go back to this off-chain backend off-chain stuff. So let's see. Yeah, so as I said, the off-chain ply is the off-chain.ply is the entry point, and this the second method is called the stack best answer, which is for the smart contract to call this endpoint to get the best answer, and the handle is the stack best answer. So if you go here, then yeah, so like I said, you don't need to worry about input. All input are identical. All input are identical. Just copy and paste the inputs. Then you need to yeah, just here. So this is a template for the prompt. I need to provide the questions and answers. So you can you can decode the input like here. And also when you get response, you need to provide the request here. So all these things are just identical, just copy and paste, don't touch them. If you change something might be wrong, then you need to go deep inside to the code and figure out what's going on. So I don't recommend that, just copy and paste. So yeah, so here is the get current launch question. So the current get launch question is basically you call this Boba RPC endpoint and use the smart contract and provide smart contract address and also the smart contract API. And you call this create question functions to retrieve back all questions. So yeah. So that's how you get the current round question, and how you get the current round answers is all the same, but this is a little different because we use the event to record the submission of the users. So you need to use the get logs by providing the game ID and also the front block and the last block. Then we'll call it off-chain and call the blockchain and use the events get logs to get back all submissions. Yeah. So yeah. So once you get that, then you can. Once you get the question and the answers, you basically provide the question and answers to a ChatGPT. But something you need to be careful is because you want to provide also this index for ChatGPT to select. If you ask ChatGPT to select the address, something might go wrong. So you have to provide this index for ChatGPT, like here, like index 0 is some answer, index 1 is some answers, something like that, to provide the ChatGPT in the templates, providing the current question and answer list. So, and now finally we can provide everything to launching OpenAI interface. So yeah, so go here, provide the model you want to use. It's OpenAI model. Then provide the input prompt. Then you select the best answer. Then you strip out those slash dash like those kind of things. Then now you finally can get the index. Yeah. So we get the index. Okay, good. Then you found the index, you can get this address. So this is here, you can use the index to get the address. And you encode everything to a response, and you build the final response. Like I said, you don't need to touch everything. Just be careful, you don't need to touch your request, IUQ request. So what you need to build is just a response. So just you build the response and provide this SDK generation response and return it. Then the smart contracts can automatically handle things for you. So now we go back to the smart contract side. Yeah, like here, so if you return a response here, the arrow means the arrow code. If arrow code is 0, that means everything is good. Don't worry about it. Then if you then you can just decode the return because we know its address. Then just decode it as a address. Then you finally know okay who the winner is. Mint function is basically the feature that you can mint a certain token to this winner. But yeah, that's just the extra feature. I think the core idea for the HybridCompute it's very clear now, and you guys how to know write these kind of things. Yeah, so do you guys have any questions or something like you guys interested in that I can explain to you guys? Just let me know. I can answer anything you guys have from the code side or from the SDK side. Yeah.
Amazing. Thank you so much, Boyan. That was really, really clearly explained, and it was great walking us through the code there. Yeah, if anyone has any questions, feel free to pop them in the chat now. Like everything, like all other workshops, this will be recorded and uploaded on our YouTube channel. It will come tomorrow. I think we've got a question there from Mohammed.
Yes, so basically you can provide anything only if this answer can be decoded by the smart contract. So let's say you can provide a very, very, very long string. That doesn't work for a smart contract. So you have to make sure that anything you provide, for example, you want to provide a list, that's okay, smart contract can decode it, but you have to make sure that, for example, the length of this list or the array is fixed. So the smart contract can decode it. So you have to be specific with the smart contract side. Yeah.
Great. Any other questions? Feel free to put them in the chat. Boyan, do you potentially have the link to the slides that you could share?
Yes.
Really
Let me
helpful.
share how things can be shared.
Great,
Anyone's
thank you.
link. Yes, copy link.
And the GitHub link is already in the chat, so that's great. We will also circulate that to participants soon as well. And that was a really great workshop. Thank you everyone as well for coming and attending. And yeah, I hope to see you guys at the next workshop.